Hello, welcome back to Math with Patrick. Today is February 18th, and we got problem number 49 to solve from that Daily Epsilon calendar. All right, we got a geometry problem. We are given stuff about the angles. Looks like these two sides are congruent. And ultimately, we need to solve for x. Apparently, x is 18, so that's today's date. All right, where should we even start? Well, here, I want to start with these tick marks. It looks like, we are given an isosceles triangle. Isosceles triangles have two congruent sides. And kind of just because of the symmetry, they also have two congruent angles that kind of correspond on those sides with the congruent sides. And that lets me label a 2y in this bottom left corner. It wasn't there in the original diagram, but I know that that's going to be another 2y because of the isosceles triangle. And I guess I could add up all of these angles, 2y plus 2y plus 2x. And it's a pretty commonly known fact that adding up all the internal angles of a triangle gives you 180 degrees. Okay, I could simplify this equation even further. I could halve everything. So I have y plus x is 90. And then why not? Let's combine those two y's together. Okay, so I have some equation that relates x and y. And I'd like to make another one, because if I have two equations and two unknowns, then you're able to solve for both. So if I look at the big triangle, the one made up of the two smaller ones, I know that I have an angle of y here, and then 4x in this corner, because I'm just adding both of those two x's. And then this is still a 2y in the bottom left corner. So if I do the same thing here, I get 3y plus 4x is equal to 180. And this is now a different equation than the one I made at the start. So it's a good sign that I will actually be able to figure out what y and x are in this diagram. And I can't simplify it in the same way that I did up here where I divided everything by 2. So you know what? It might actually be easier to take a look at these two equations and compare those ones. Because on the left equation, I have 4y plus 2x equals 180. And then in this equation on the right, I have 3y plus 4x equals, 180. So I don't have to write it again. And this 180 degrees acts kind of as a bridge. So now I know that 4y plus 2x is equal to 3y plus 4x. Here, I have this equation. So I'll use this one, and I'll use this one. Maybe I'll do a little bit of substitution. And ultimately, I am solving for x today. So if I sub out the y, that would be better for me. So if I isolate y, I could get, let's see, y is equal to 90 minus x divided by 2. So I subtracted this x, and then I divided by that 2. And then for every time I see a y, I can just stick this 90 minus x divided by 2 in those spots. And then 3. You know what? Let me simplify this equation first. Hold on. I don't know why I was substituting in all those things when I could just subtract some y's on both sides. There we go. And then now I have 1y over here plus 2x equals no more y's, 4x. There we go. So this feels a little bit better. I'll do that substitution now where I'll plug in that 90 minus x over 2. You know what? I'll do it like that. You're allowed to split up division like this in fractions. And the 90 over 2 is just a 45. There we go. So if I collect up all of my x's, then I should be able to compare it to this angle. Well, over here, I have 2 and then half, or minus half in x. So that makes 3 halves x. But then I want to subtract all of this from the right side. And I think that'll leave me with 2 and a half, or maybe 5 halves x would be a bit better. Okay, one more step. To undo multiplying by 5 halves, I like to multiply by the reciprocal. And so if I multiply by 2/5 on both sides, I'm not changing my equation because I'm kind of keeping it balanced, but this does cancel out the 5 halves with the 2/5. And 45 divided by 5 is 9. And 2 times 9 is 18. So x is equal to 18 today, and that was today's date. And so we're all done. One thing I kind of noticed from the start, this triangle actually showed up in our January 20th problem, where I was trying to figure out stuff about, I think it was pentagons or something like that. I was doing, it was like sine of pi over 10. And so something about trying to find more information about this pi over 10 angle measurement made me come across this triangle. This golden triangle is one that has angle measurements of, let's see, x was 18 today, so 2x is 36. And then both of these together make a 72. So this is a 72, 72, 36 triangle, because if you add up all of these, you get 180. And it has this property where if you find another smaller version of it inside of itself, it's another 72, 72, 36 triangle. And it kind of just goes triangles all the way down. Like you could maybe find a third golden triangle in here. Let's see, how would it be placed? Maybe you'd split it up kind of like this, or maybe you'd split it up kind of like that. And either way, you get another one of these golden triangles. So today's answer was 18, and it just reminded me of that January the 20th problem. So go watch that video if you want to hear a little bit more about golden triangles and how it can help you with other problems. So anyways, X is 18. We're all done. I'll see you tomorrow. Thanks for coming along.